Okay, so in this class we'll do the question number 36 on your tuition note, which is simply the sign conventions, or it is also called new Cartesian sign conventions for reflection by spherical mirrors. Now this is absolutely important to understand, okay, if we are going to do the numericals with ease without having difficulty. So let us draw a margin like this, left, right on your notebook, about half a page maybe, and draw here. On the left side you draw a line, and on the right side also you draw a line, and we'll see what we'll do with this. Now on the left side, let us say we took a concave mirror, and on the right side you draw here again convex, let us say. So we know concave means on the left we'll mark C, because we're going to put this is concave mirror with the reflections facing left. That's the rule. That's the first convention, okay? Mirror should be to the left, whether convex or concave. So for that, the curve is like the spoon, so you have to draw C here, the curve like this. So take around 6 centimeters maybe and draw an arc. Mark your P, half of 6 is 3, so mark your F quickly. And let us deal with this concave first. Now here, okay, you can draw your concave up here maybe to have some space down. Concave, and here just write convex. Okay, so here, so we have space down here, I mean. So here, just draw an object wherever you like, you can place it. This will represent our object. Now we have to, first sign convention is mirror face left, so non-reflection side is on the right and reflection is on the left. So object should be on the left, that is the convention. Okay? Convention is like a rule that we decide to follow. So this is your object, let us say. Okay, and then go back to your formation of image by concave that we did two classes back, I think we did that one. You go back and you will realize that concave can form two types of images. You remember? First one was real inverted and on the left. So let us say just a ray, just pass it so that we can understand what we're doing. A ray parallel, incident ray, will go to focus. And we know that every real inverted image will be, this is the reflected ray, will be on the left. So let us say this represents all the real inverted image. Here you write down real inverted in short. So this is the real inverted image. And we know when we did this formation of image by concave, every real inverted image was in front or left side, so it's on the left. Right, this is the mirror, so this is right side, left side. So every real inverted image is like this. So this will represent all the real inverted image because they are all on the same position, left side. That in the case 6, the last case, when you put the object between P and F, we got a virtual erect behind mirror, which was taller than the object. So let us draw here an object which is taller than the, here, this is the, image. In case 6, when the object was between P and F, image was virtual erect behind mirror and magnified. You remember, right? Magnified. And I showed you with this one here, between P and F means close to the mirror. Look at my thumb. The image was behind it. The only case where it was behind mirror was this, object between P and F. And the object was taller, you see. Today also you can see there my thumb is so close to the mirror that it is between P and F. So can you see from the camera, can you see? Right, so okay, so can you see here from the camera? Yes, see there. Okay, there, see. Let me just show you so that it is bigger or not, see. Clearly bigger than my thumb, right? Behind the mirror. So you will see there. Agree? So that is the case. So let us take it like that. Now this is the virtual erect image. So we mark the virtual erect in short. You can do it, virtual erect. Okay, so here, virtual erect. So this is the mirror that can form both type of image, real inverted on the left or virtual erect on the right side. So let us see now, the sign convention runs like this. Let us measure this distance between P and F. Let us start with that. Now we know, we have learned this from our previous classes also, that the distance between P and F is called what? Yes, that's right, focal length small f. So you see focal length small f is measured, this is the middle line, P, okay, starting from P, every distance will be measured from here, okay. So on the left means it will be minus, this is called sign convention. Any distance measured on the left of the mirror is minus. So focal length of a concave mirror, remember today, it is minus because it is measured on the left, okay. Then here, what is this distance called? Distance between the image and the pole. As I said, the sign convention is all distances should be measured starting from P. So this distance from P between image and P, this one is called the, how far the image is from the mirror is called image distance V. So image distance V is on the left, so it is minus when it is really inverted because it is measured on the left. That's the sign convention. Another one here, you see, distance between C and P, we know now, we have learned in previous classes the definition for this distance between C and P. Do you remember? That's right, radius of curvature, which is denoted by capital R. Again, this is measured on the left side of the mirror. See, mirror is here, see, P line. Left side, so radius of curvature of concave is always negative. Then how about this? The distance between the object and the pole. How far the object is from the mirror or pole. What do we call this one? Distance of the object from the mirror. That's right, object distance U. It's measured on the left, so it is minus. So please remember, since we are putting our mirror facing left, whether concave or convex, object will be always on the left, so U will always be minus. It's impossible to get U as plus because we cannot put object behind mirror. No reflection will take place, right? So that is something we have to remember. Then how about this? The distance between this virtual image, because there are two types of image here. I'll draw with the same line with this V here. The distance of image from mirror is called V. Just like this V. Distance of real image from P, virtual image from P. It's on the right this time, so it is plus. So notice the difference. When concave mirror form real inverted image on the left, it is minus because it's measured on the left. When it forms virtual erect image on the right, V is plus because it's formed on the right. Please keep that in mind. Both are possible, right? Now, one more thing here. M formula, okay? Magnification formula for mirror is HI by HO, height of image by height of object. Just write that down and come up here before you go. Now, height, that is the distance that are parallel to the principal axis, F, all this. But there are some distances above this principal axis and below, like this is below, this is above principal axis. So the actual height of the object is called object height, HO, usually. Anything above the principal axis will be plus, okay? So now we are coming to know here that, look here, anything measured on the right of the mirror is plus, on the left is minus, we know that. Anything above is plus. Again here, so this one, height of the image is called HI. Anything above the line principal axis is plus. So HI is plus when it is virtually erect. Now how about this here? This is also height of image HI, another type, when it is really inverted. Below the principal axis, so it is minus. So when it is below the principal axis, then it is minus. This is called the sign convention. Because this is very similar to the graph Cartesian that we use, it's also called new Cartesian sign convention. Just like when you draw your graph on your graph paper, on the right side of origin is plus, left side is minus, up is plus and down is minus. It's similar to that, right? That's why it's also called new Cartesian sign convention. Okay, now coming back to that M. So M formula is this one. So there will be two M here. M value when it is real in inverted, let us say. When real in inverted, HI is what? Minus. See, this one. HO is always plus, so minus by plus is minus. So M value will be coming out minus when, okay, M value will be minus when it is real inverted because HI is minus in that case. But there is another M here. H will be plus or can be plus. You can say like that. When it is virtual erect, what happens? Virtual erect, check once. Virtual erect, then HI is plus or not. See, this one is plus and HO is always plus, so plus by plus is plus. So M value will come out as plus 2, plus 1 like that when the image form is virtual erect, because HI is plus, right? So these are the two. M can be minus also or plus also for concave, depending on whether it's real inverted or virtual erect. Okay, now let us go to the convex mirror. For that, we mark our C on the right side and we draw 6 cm arc like this, so that reflection is facing left and non-reflection is on the right, like this mirror curving out. So the curve is like this, curving out. So the center should be this side, on the right side, isn't it? So that's why we're putting the pin of the compass this side. So this is P and half of this you mark F. And now this is quite easy because here you draw object. So let us say this is your object. It's quite easy because only one type of image is formed. Then you draw here a ray parallel to principal axis. And this ray will look as if it's coming from the focus, we know that. So you can draw that quickly and it's like this. Okay. Okay, finished. Then we know that all the images are on the right side. Convex cannot form image on the left side because it doesn't form real inverted image. So this is the image. So this is the image, virtual and erect. For convex mirror, it cannot form real inverted on the left like this. So it's going to be very easy sign convention. So let us measure those distances and find out the sign convention. Here, between P and this object. First, this is called object distance, U. It's on the left. So just like concave, U is minus here also. U is always minus because we cannot put object behind mirror, right? Then here, let us measure the next one. Distance between this and the image here, virtually erect. Then this is the distance of the image from the mirror is called image distance V. Measured on the right side, so plus, right? Then here, between P and F, we know that the distance between P and F is called focal length, right? Small f. Can you see here? It's measured on the right side of the mirror, small f, so plus. That's the difference with this f here. Concave is on the left, so or minus. But here, convex, so focal length of a convex mirror is always plus because it's measured on the right. And concave always minus because it's measured on the left. Sign convention, okay? And then here, distance between C and then this P. So if you measure this, we know this is called radius of curvature. You already know very well by now. Distance between C and P is called radius of curvature. Measured on the right, so plus. Here R is minus because measured on the left, concave. But convex is always plus, right? And then M value, there will be only one. Always plus because it form only virtual erect. It cannot, this mirror cannot form real inverted on the left. So M value can never come out negative while solving numerical also. Keep that in your mind, okay? So that's how we know the sign convention. So from today, any distance measured on the right is plus, or the left of the mirror is minus. Above the principal is plus, above the principal axis, like HI, HO are plus. Anything below principal axis, like really inverted image, are minus. That is the sign convention. Right side plus, left of the mirror minus, above the principal axis plus, below the principal axis minus. I repeat again. So if you know the sign conventions well, then numericals shouldn't be a problem. Okay.